So an atomic level view. So we're going to go in and look at what the atoms are doing in elements and compounds. We can take elements and divide them into two categories, atomic elements and molecular elements. So here's a flow chart. You've got pure substances are in two categories, elements and compounds. The elements, and we've talked about those, the elements can be broken down into atomic elements and molecular elements. And the difference is, what are the individual atoms doing? In an atomic element, you have individual atoms, and they're held together by forces. In a molecular element, you actually have discrete molecules made from the atoms. So in oxygen, we have oxygen molecules. An oxygen molecule is two oxygen atoms with a covalent bond holding them together. So when you look at the individual particles, here we have two atoms, and here's just a single atom. So this is atomic, this is molecular. When we look at compounds, this comes down to what kind of bond is holding the compound together. In a molecular compound, we have covalent bonds, and that gives us discrete molecules. In an ionic compound, we have ions and ionic bonds, and those ions are going to arrange themselves in this lattice, kind of like, magnetic building toys. They're just going to kind of click together. Electrostatic charges behave a lot like magnetic fields, and so you can imagine these as being magnetic, and they just stick together. And if you bring more in, they're just all going to stick together. That's not going to happen with water. Each of these particles, these molecules, is two hydrogen atoms, one oxygen atom. And then those molecules can interact with each other, but they don't form bonds with each other. Okay, so that was the overview, and we'll go through it again. Atomic elements exist as single atoms with their basic units. And most elements are atomic elements. Molecular elements exist as molecules. They're going to have two or more atoms of the same element bonded together. So there are 7 diatomic elements. Di is a prefix meaning two. So these are 2-atom elements. And here they are with their formulas. So if we have hydrogen as the element, it's not individual hydrogen atoms. It's going to be hydrogen molecules, H2. I think of these elements as being a little bit like junior high girls. Someone pointed this out in an assembly when I was in junior high, and I noticed that it was true, and I even did it myself. At school, junior high girl needs to go to the restroom. She's going to take a friend. It's this weird thing about junior high girls. They always take a friend, right? They're found in pairs. I found myself doing it even after they pointed it out. So these are like junior high girls. They don't go anywhere by themselves. They're always going to have a friend with them. So they go out in pairs, kind of a buddy system. That applies to the element only. If they are involved in a compound, they don't need the girlfriend anymore. They're with some other element and they're fine. But you're not going to see hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine atoms by themselves in nature. So those are diatomic, and we need to memorize those guys. 2 other ones that are polyatomic elements, and you should know that these exist, but I'm not going to test you on them. Phosphorus and sulfur can form polyatomic molecules. So you can have phosphorus 4, P4, and S8. And those are kind of weird. So here's chlorine gas. It's got diatomic molecules. So I think of each of these atoms as being a junior high girl, and they're going around together. So here's a periodic table highlighting the molecular elements. So I mentioned phosphorus and sulfur. Selenium is also one of those. So I'm telling you about them, but I really don't care if you remember those guys. It's the yellow ones that we absolutely need to keep track of. So there's different ways to remember these. One of the patterns I noticed in the periodic table, and it's just, I noticed patterns. So there's 7 diatomic elements, If you go to element number 7 and make a 7, those are most of them. And of course, then there's hydrogen. He's got to break all the rules, be an exception, and do his own thing. So hydrogen's over here. So if that works for you, that's great. Another one is Brinkelhoff. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Somebody just put the symbols together so that you could sort of pronounce it. Oh, I didn't really leave myself much room. But my favorite is this sentence, horses need oats for clear brown eyes. So everything's great until we get to the eyes. We can remember that though. So the first letter or two letters, H, N, O, F, Cl, Br, and I. So those are the ones that are diatomic. Horses need oats for clear brown eyes. You need to memorize those. So the compounds, molecular compounds of molecules. So the molecule is usually two or more covalently bonded nonmetals. So nonmetals together are going to form molecular compounds. If you have a metal and a nonmetal, they're going to form an ionic compound. So the basic units of molecular compounds are molecules of the constituent atoms. Here we have an illustration of propane, which is, you might have one of those on your back patio for the grill, right? These are propane molecules. They are discrete particles. They're all the same as each other. It's a molecular compound. The formula for the molecule is C3H8, 3 carbons, 8 hydrogens. Water is a molecular compound. It's two nonmetals, hydrogen and oxygen, and they form water molecules. Dry ice is solid carbon dioxide, two nonmetals, carbon and oxygen, and the molecules are CO2. CO2 is different than CO, which is carbon monoxide, and that's poisonous. Propane, carbon, and hydrogen, again, two nonmetals. So if you have two or more nonmetal elements, that's probably a molecular compound. Ionic compounds have ions in them. We're not trying to be tricky with these names. So ionic compounds, you have to have at least one positive and one negative ion. So you've got cations and you've got anions. The cation is usually a metal. The anion is usually one or more nonmetals. And what holds the compound together is the ionic bonds, the forces of attraction between the positive and the negative charges. So the smallest unit of an ionic compound is not a molecule, because a molecule is a discrete particle with a fixed number of atoms in it. In an ionic compound, we have this just arrangement of alternating atoms. And if we put some more sodium and chlorine in there, they're just going to stick and add on. And so there's not one discrete particle that we can point to. In essence, each of these salt crystals is one ginormous molecule. But it's not actually a molecule, because each of these crystals is going to have different number of sodium and chloride atoms. It's just that the ratio is the same. So molecular compounds have molecules, discrete particles with specific numbers of atoms. In an ionic compound, you just have a ratio of cations to anions. And so we call that smallest unit a formula unit. And the formula unit is the smallest electrically neutral collection of ions. So for sodium chloride, this molecule has a lot of sodium ions and chloride ions in there. Instead of trying to figure out how many there are, which would be different in each of these particles, we're just going to look at the ratio. So for ionic compounds, we're always talking about an empirical formula. So we're going to look at the formula as being NaCl. Cl, because we've got a sodium ion with a positive charge and a chloride ion with a negative charge. And we need one of these for every one of these, and so it's a 1-to-1 ratio. So this is the formula unit. You don't actually see the formula unit in the substance. It's just the smallest ratio. It's the empirical formula of the ionic compound. Any questions? You guys are really quiet. So, ionic compounds can contain ions like we've talked about, like sodium and chloride, where it's just a single atom that's gained or lost electrons. We can also have more complicated ions. They're called polyatomic ions. Poly means many. So this is an ion that has many atoms within it. So within a polyatomic ion, you have some atoms that are covalently bonded together. What makes this different from the molecule of a molecular compound is that that group of covalently bonded atoms has a charge on it. So an example here would be the nitrate ion. So a nitrate ion is a nitrogen and 3 oxygen atoms. They're covalently bonded together, but overall, it has an extra electron, so it has a charge on it. The charge distinguishes this as an ion rather than a molecule. A molecule doesn't have an overall charge. So in this compound, we have 2 different kinds of ions. You have to have at least one positive and one negative. So we've got the sodium ion, that's the positive one, and the nitrate ion is the negative one. Now hopefully this formula is a bit familiar to you because that was one of the ones I asked you to memorize for the memorization quiz. Calcium carbonate has a calcium ion and a carbonate ion. So these polyatomic ions are generally nonmetals that are covalently bonded together. Their formulas are not anything that you can just easily predict. We can predict the charge on the sodium ion. We can predict the charge on the calcium ion based on its position in the periodic table. We've looked at that. You can't just predict the formula for nitrate. That's why I told you to memorize them. They just are. We can investigate and try to understand why they are, but there's not a great way to predict them, so we just have to memorize them. Any questions? In Chem 1A, ionic compounds are always going to have 2 ions. One positive ion, one negative ion. So when you look at a compound like this and you're trying to figure out what the ions are, the first ion is the positive one. That's a metal. Metals are always positive ions. And then if you block that off, that's the cation. Everything else together is the negative ion. You're not going to say that this is a potassium ion, a chloride ion, and an oxide ion. We're not going to break them into 3 ions. In Chem 1A, there's only 2 ions. Of course, there do exist compounds that have more, but we don't have to talk about them, so we're not going to. So, classifying substances. We're going to learn how to name these substances. And the first step is to be able to identify what category they belong to. So we need to identify these as atomic elements, molecular compounds, or ionic compounds. So let's look at this first one. We're given the name, fluorine. Is that a compound or an element? It's an element. Okay, so it's an element. I get tired of writing all these words out, so I'm just going to write E for element. Is it an atomic element or a molecular element?
Molecular.
It's molecular. Because it's one of those 7. Horses need oats for clear brown eyes. Fluorine is a diatomic element. How do you know that? You memorize it. Okay? So this is a molecular element because if we were to write the formula for that, it would be F2. 2 fluorine atoms covalently bonded together like the junior high girls going around together. Any questions? Oops. N2O, compound or element? Compound. So this is a formula, and it's easy, once you see it, it's very easy to tell an element from a compound, because here we have two capital letters. That indicates that there's two different elements, so this must be a compound. So this is a compound, and then we're supposed to identify, is it molecular or ionic? Molecular. It's molecular. To identify molecular or ionic, we're going to look at, are these metals or nonmetals? So the first one, nitrogen is a nonmetal, oxygen is a nonmetal. Two nonmetals make molecular compounds. How about silver? That's an element. Is it molecular or atomic? Atomic. So it's not one of the 7, and I will not try to trick you on an exam with phosphorus, sulfur, or selenium. There are things where I will try to trick you, but I'll usually point those out to you. So silver, it's not one of the 7, so it's an atomic element. K2O. The compound, ionic or molecular? Ionic. So potassium. You probably don't associate potassium with being a metal. So potassium is this nutrient you get from bananas, right? And it keeps you from having cramps when you exercise. But when we look on the periodic table and find potassium, it's far over on the left side. It's with the metals. Potassium, the element, is a metal. So here we have a metal and a nonmetal. That tells us it's ionic. How about Fe2O3? That's a compound. Is Fe a metal? Yep. It's a metal, it's ionic. Okay. So as we learn how to name these, we have to identify molecular compound or ionic compound. And really you only have to, most of the time, like 99% of the time, you only have to look at the first element. If the first element's a metal, it's ionic. If it's not metal, almost all the time it's going to be a molecular compound.